ElasticLend. ElasticLend is a cross-chain learning protocol that applies elastic risk-taking theory to collateral management. Diversified portfolios get more borrowing power, while concentrated portfolios they get less borrowing power. No learning protocol does this today. Okay, let's go to our abstracts and equations. Okay, this is the abstract of the paper. You can see the borrowing power formula and the elastic is taken power by Bar-Zur and Eyal. It proves that elastic allocation is strictly more robust than rigid. We discovered that lending collateral portfolios are socially identical to risk-taking networks. The paper's theorems they apply directly to this. The rigid model sum losses linearly, while the elastic models take the square root of the sum of the squares, compressing uncorrelated risks. Let me key this our portfolio simulator. Okay, this is our portfolio simulator. I'll be showing you. Let me switch them off. I'll be showing you the difference in elastic and rigid borrowing power for under different portfolios. Let's go. Okay, let's start with depositing Ethereum. Let's deposit 5 Ethereum. The rigid borrowing power and elastic borrowing power, they are equal here. They are the same. This is because of this fact that this is a single asset. No diversification, so there's no benefit. So let's say I add USDC. Let's say I add 5,000 USDC on Arbitrum. We can see, like, as you can see, this is like just the fact of that there are different risk group. We can see the elastic borrowing power jumps, while the borrowing power grows proportionally. Let me add Bitcoin WBTC. Let's say I add 0.2 WBTC. We can also see adding this third risk group, the elastic advantage, it keeps going, compared to the rigid borrowing power. And let's say, okay, let's also add link. Let's say I add 300 chain tokens on Ethereum. Let's add 300 Ethereum here. Okay, yeah, as you can see here, on adding 300 chain tokens, we can see this making it the 4 risk group. The elastic borrowing power is at 2,777, while the rigid borrowing power is at 18,732. This is a 27% advantage for the same collateral value. The HHI concentration, the MDA OFAM index, this concentration is at 3,259, which means this is well diversified. The FOFAM index, this measures concentration by is a tier system. The maximum point is 10,000. This means a single group. While the lower the number is, the more diversified the portfolio is. Okay, as you can see. Okay, this is our cash simulator. We'll be simulating what will happen if each of these risk group crash, if the crash occurs. Let's look at it here. Let's say from the first figure above, our total debt is $18,000. At zero crash on any of these tokens, we can as you can see here, we can see that the rigid survive, but it's at 1.04, while the elastic borrowing power also survive, is at 1.22. Let's say this instance now I borrow $18,000. Both model tell me the position is safe, but the safety margins are very different. You can see the rigidities are 1.04, while the elastic F factor is at 1.32, which is, and as you can see here, the elastic F factor is more comfortable than the rigid. Thereby, the elastic borrowing power has more headroom because of the portfolio is diversified. Okay, now let's simulate let's simulate crashes. Let's say let's say Ethereum token crash up to 40%. Let's say crash up to 40%. As a crash occurs. In the case of the rigid borrowing power, you can see we have 0.92, that is we are already like it's already liquidated, like the portfolio is liquidated. But in the case of the elastic L factor, the portfolio survives. It's at 1.15. As you can also see, like what you can see the grades here. Same portfolio, same cash, same debt, but the rigid borrowing power treats every asset independently, while the elastic borrowing power sees diversification throughout BTC, USDC link, absorbing the shock that happens to Ethereum. Okay, as you can see, let's say, as you can also see the chart we have here. It shows us clearly the rigid. As you can see the rigid borrowing power line, it clearly crosses below the threshold, while the elastic stays above. And do you have enough time, guys? Okay, let's talk about the last part of our video here, which is our this is what we call the stretch effect. Okay, let me start explaining to you. You can see here, you can see the portfolio bars we have here. The elastic model, it does something no other protocol does. Look at our BTC bar. Look at our BTC bar here at 43.2%. That is the most concentrated. Is the most concentrated here. Okay, let me explain what this bar we have here. This bar shows each risk group collateral value. Like, it shows the collateral value of each group, and as you can see the collateral value of BTC here, it is the most concentrated position at 43%. Okay, now let's watch what happen. Let's watch what happen here when we liquidate the most impaired. And as you know here, the most impaired here is Bitcoin. Why? Because it has the most concentrated collateral group here. Okay, let's click liquidate most impaired. Okay, as you can see our new chart, 50% of the BTC position is seized. But look at the borrowing power per dollar metric. It went up. It went from 73% to 74% to 7.8%. This shows that the main portfolio after the liquidation applied to the most concentration one, it shows that the money portfolios are more diversified. Which is the fact that we have liquidated the most concentrated this group that we have. This makes the collateral stretched. And this is the section 3.4 of the paper that says that when a service fails, the remaining allocations expand to cover surviving obligations. Okay, we don't have enough time. Okay.